Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 5B Part 1 assignment. First one is number 1 here. Decide whether these sequences are arithmetic. So if they're arithmetic, you have to add the same number each time. Add or subtract the same number each time. So let's see what we do. Let's see, 7 plus 8 gives us 15, plus 8 is 23, plus 8 is 31, plus 8 is 39. So yes, this is arithmetic. Okay, that number has to be the exact same each time. Number 3 here, for each of these arithmetic sequences, state u sub 1 and d. Okay, so u sub 1 is the first term. So u sub 1 is 19, and then the d is the difference, what it's changing by each time. So let's see, plus 6, plus 6, plus 6. So our d equals 6. Okay, find the formula for the general term u sub n. So now we can take this u sub 1 and d equals 6, plug it into this formula here. So we'll get u sub n equals, u sub 1 is 19, plus n minus 1 times 6, right? So we get u sub n, 19, distribute this 6 to both of these, and we get 6n minus 6. So we end up with 6n, and then 19 minus 6 is 13. That's our general formula. And an easy way to check that is just plug in 1, 2, and maybe 3 and see what happens. If we plug in 1, 6 times 1 is 6, plus 13 is 19. We plug in 2, the second term, 6 times 2 is 12. 12 plus 13 is 25. Plug in 3, 6 times 3 is 18, plus 13 is 31, so forth and so on. So we know we have that right for sure. Okay? So we've done those two, and then 3, find the 15th term of the sequence. So now that we have our general formula, now we can find the 15th term by changing n into 15. So we do 6 times 15 plus 13. So the 15th term, 6 times 15 is 90, plus 13. So our 15th term would be 103 for this one. Okay? All right, let's take a look, at number 4. Consider this sequence. Show that the sequence is arithmetic, okay? Now, what you want to do to show that the sequence is arithmetic, you got to show that the difference is the same each time, and you got to do it at least 3 times. Okay, so we would do this. 17 minus 6 gives us 9. That's this minus this. And then we'll do 28 minus 17. That also gives us 9, and then do 39 minus 28. Oops, these are all 11s, not 9s. Don't mind me. 11 and 11. Okay, so that shows that all the differences are the same each time. So that's part A. So we've shown that it is arithmetic. Also, another way we could do that is to simply, we could also write down that the first term, u sub 1 is 6, and then the common difference is 11. Okay, that is also showing it. But this here proves it. Okay, anyway. B, find the formula for its general term. Here's our general term formula. We know that we've got u sub n equals, our first term we know is 6. N minus 1, and then our difference is 11. And now just simplify this. 6 plus, I've got to distribute the 11 to both these parts here, is 11n minus 11. So u sub n is going to be 11n, and then 6 minus 11 is negative 5. That's our general term, our general term, formula for the general term there. Okay. Part C, find the 50th term. So once we have this here, this was B, once we have this here, we can say u of 50. So our n is going to turn into 50. So we do 11 times 50 minus 5. All right, so we get u sub 50. Let's see, 11 times 5 is 55. Add a 0, so we get 550 minus 5. So the 50th term is going to be 545 for part C here. Okay, and then part D, is 325 a member? So what we want to do with that is take this 325 and plug it in, replace the u sub n, and see if it works out to be a whole number. Okay, so for part D here, we're going to go 325. Will that equal 11n minus 5? Add 5 to both sides. We get 11n equals, what's that, 330. Divide both sides by 11 and see if that works out evenly, which this one will. It's going to end up being, what, 30? So that means that the 30th term is going to be 325. So is 325 a member? Yes, it is. Okay, if this was 30.2 or 28.9 or something like that, if it doesn't work out to be a perfect integer, then that means it's not a member. Okay, is 761 a member? So let's see, we're running out of room. Let's do that over here. 761, does that equal 11n minus 5? Will this give us an integer? So add 5 to both sides. 11n equals 766. So now we're just going to want to calculate that. Got to divide both sides by 11 here. And let's see if that ends up nice. So let's do 766 divide by 11. Enter, and we get 69.6. So we do not get an integer. So that means that 761 is not a member. Not a member. Okay. Okay. Moving on to number 9. Arithmetic sequence starts like this here. Find the first term of the sequence to exceed 100,000. Okay, so what I would suggest doing is we really need this formula here. So we got to come up with this, figure out what the formula is, the general term formula for the sequence here. So let's fill out what we know. That we know that u sub 1 is 23. So we do u sub n equals 23. And let's figure out what the difference is. 23 plus 13 is 36, plus 13 is 49, plus 13 is 62. So it's plus n minus 1 times 13. So u sub n is 23 plus 13n minus 13. So our general term, our general term for the sequence here is going to be 13n. 23 minus 13 is plus 10. So this here is the formula for this sequence here, right? So what we want to do is plug in 100,000 into u sub n and see what we get. Not 100,000 in for n, but u sub n. So we're going to want to see when this sequence here is going to reach 100,000. Okay, so subtract 10 from both sides. And we get 13n equals 99,990. Divide both sides by 13 to figure out what our n is. So divide by 13 here, and we get 7691.5. So 7691.5. Now, again, remember, this has to be a integer number. You cannot have a, like, this is first term, second term, third term. You can't have like a 1.5 term or a 2.5 term or a 7691.5 term. You got to have a full term here. So if we did 7691, that would be just less than 100,000, but we want to know when it's going to exceed 100,000. So regardless of what this number is, we're going to want to make this number bigger. So n is going to have to equal 7692. Okay, even if this was a 0.1, this would still be 7692 because it has to exceed. Okay. Let's take a look at our last one here for today is 11. What can you say about u sub 1 and d for an arithmetic sequence if all of the terms are even? Well, we know for sure if every term is even, that means that the first term is even. Right? And that's our u sub 1, right? Oops, u sub 1. And then if everything's an even number, that means it has to go up by an even number also. So the difference is also even. And remember, the difference is the d. So both u sub 1 and d have to both be even if this is true. Okay? All right, that's all we have for the 5B1. If you have any questions about this or anything else on the assignment, please feel free to ask. Thanks.